Hello guys, welcome to screencast for Anatomy and Physiology exam, which if you haven't had my email already is tomorrow at 10:35. This will be focusing on cardiovascular system and the respiratory system. Okay, so exam success cycle there, when you get into that exam tomorrow, you'll have a pad where you can use. You must make sure you read that question, you look at how many marks it wants, and you align that with the number of points. You also should be circling the important bits of information. So is there anything in there that can kind of, I don't know, does it need sporting examples? Because it linked to a memory method. Then we'll have a look at a few memory methods that we can use today for cardiovascular and the respiratory system. Then we need to be able to translate them and then put them into with an example or extend it using technical terminology. So that's our key focus. I'm going for about 8 to 10 questions that I just want you to have a look at for tomorrow. Okay, they are as follows. So going on, describe the functions of the cardiovascular system. You're looking for about 5. For those, we'll pause it now, and then if you want a memory method, I will go on to that now. I thought this would be quite a good one. Cardiovascular functions of it. When you have these kind of functions, I think it's quite good. You think cardiovascular, you think about cardiovascular disease. So when you think of the functions of them, if you think about cardiovascular disease, you have to go to the doc, and then I've just kind of changed it. Sorry, so doc with double C and 2 T's as well. Okay, so going on from there. Okay, what does that translate to? D, disease, protects the body against disease. Oxygen, circulates oxygen around the body. Carbon dioxide, circulates carbon dioxide around the body. Clotting, it prevents the clotting of blood. Temperature is controlled by thermoregulation, remember that 37 degrees. And then finally, transport of hormones around the body. Doc, TT. Okay, so that's something you could use maybe if you wanted to practice for tomorrow's exam. Going on. Describe the structure and function of arteries, veins and capillaries. You need to have one structure, 2 functions. If I said to you now, I feel like I'm going to give you a memory method, and I think that memory method should allow you to be able to answer all 3. Now I'm going to look at arteries as a way of remembering things. So, arteries. So you're going to spell arteries with a capital A, capital T. A is going to link to away. T is going to link to thick walls. So you know that artery straight away. The structure is it has thick walls that carries blood away from the heart. And then we just have to find one more functional characteristic, which would be to do with pressure. So once you can do that, you can pretty much go across then and talk about the other ones, I think. So hopefully, just pause it now and see if that can help you kind of get at least one structure, 2 functional characteristics of arteries, veins, capillaries. Answer. Okay, so have a look on there. So arteries, thick elastic walls, functions carry oxygenated blood away from the heart, blood carried under high pressure, and then you go through the other 2 here, which is what I just wanted you to do. So pause it, check you've got it. Okay, moving on. Next one then, describe how thermoregulation operates if internal temperature rises. Now firstly, you might get a question asking you what the optimal body temperature is. And obviously that's 37 degrees. So you need to know that. However, what we looked at, remember, is this quite tough topic of how thermoregulation operates if internal temperature rises. So when we start to get hot, okay, what is the process by which our face goes red? So there's a vasodilation of vessels. Okay, and the vessels are arterioles. So vasodilation of arterioles under the skin. They increase in diameter. You don't have to have that if you don't want to just increase in size. They get wider. Increase in blood flow to the capillaries under the surface of the skin. And then heat is lost through the skin via radiation, sweating, etc. and has a cooling effect. So that is what happens when we get hot. That's why our face goes red. That's why we sweat. Okay? So that's what I need you to do. What are your key things here? Vasodilation has to be in. Arterioles has to be in. Under the skin has to be in. If you don't have to put dilate, you need to have this, increase in blood flow to capillaries, and heat is lost via radiation and sweating. If you just want to do, if radiation doesn't make much sense, you just put sweating. Now, the opposite, of course, is we're looking at describe how thermoregulation operates if internal temperature falls. So when we get cold, so obviously we're kind of thinking you should be able to have a transferable amount of knowledge here. So you're thinking, okay, the opposite. Vasoconstriction of arterioles under the skin, decrease in diameter. So basically you just need to say vasoconstriction. That means the tightening, okay, the narrowing of blood vessels, or arterioles, sorry, under the skin. Decrease in flow of warm blood to the capillaries under the surface of the skin. So very little heat is lost by radiation, and blood is redirected away from the surface of the skin to the body's warm core, thus reducing heat loss. So you can have a go now, have a go at that. Ultimately, what do I expect from you? Could you talk about vasoconstriction of arterioles under the skin? Exactly the same as what we just talked about, but the opposite. Okay, decrease in flow of warm blood to the capillaries under the surface of the skin. So your job to have a look at that, see if you can answer it. Going on then. Describe the structure of the respiratory system. What is the order of the kind of, from when we breathe in, what's the order? Okay, I'll show you onto here then. So, see if you can pause it, see if you can remember. So you start and remember with the epiglottis. Take it from there. So you should be going epiglottis, trachea, lungs, bronchi, bronchioles, alveoli, diaphragm, intercostal. So remember we went through epiglottis, trachea, bronchi, bronchioles, alveoli. Okay, so these two aren't so important, but they're the key bits you will need. Nasal cavity, air is warmed, okay, by blood, filtered by cilia, moistened by mucus. Trachea, strengthened by the rings of hiding cartilage, if you want to put that in. And there's also pleural membranes, which are lining lungs and thoracic cavity. So basically, you might need to have something a little bit on pleural membranes. Ultimately, you need to make sure you can talk about the epiglottis, the trachea, the bronchi, the bronchioles, and the alveoli. Okay, and remember this stuff here. Warmed by blood, filtered by cilia, moistened by mucus. Make sure you know about this nasal cavity, okay, which will probably be your first point. Okay, going on then. Describe the mechanics of breathing for inspiration. Now, there is a memory method for this. So again, you've got breathing problems. Imagine that. So as soon as you see breathing, you're thinking, right, the mechanics of breathing. I've got to think about breathing it. If I have breathing problems, I will go to the doctor. Okay, so what you're going to do here, okay, so remember we use that kind of doctor, VP. Okay, so or you could have D or D, VP. And what you have to talk about is, can you translate what these letters stand for and what happens when you breathe in, which is the other word for inspiration? Answer, diaphragm flattens. Remember, the external intercostal muscles contract because it's always the opposite to whether it's inspire. If it's inspire, it's always the external intercostals. If it's expire, it's always the internal intercostals. The ribs rise, volume increases, and the pressure decreases. Okay, causing inspiration and the air rushes into the lungs. Now, the next bit, of course, should be very easy now. So we're kind of thinking we've just got to know one of these because we can chunk the information and look at the next one. So you go in. Describe the mechanics of breathing for expiration when you're breathing out. Exactly the same. So what happens to the diaphragm? Which intercostal muscle works? What happens to the ribs? What happens to the volume of air? And what happens to the pressure of the air? Absolute opposite. See if you can work out that. Pause it and have a go at writing it. Diaphragm moves up. Internal intercostal muscles contract. Ribs move down, volume decreases, pressure increases, expiration, air rushes out the lungs. Okay, so that is the end of the kind of revision screencasts. Now, just remember, the one thing I haven't put on here was what I gave you today, which was the kind of model answer for transport of blood around the body. So basically you've got that as well, which you can add on to what I've done tonight. There's a good chance that'll be a 10-mark question. I gave you a model version today. Please make sure you use that. Do not be late for tomorrow's exam. It's in 3.1 Computer Suite 1. Okay, thank you very much.